Hello everyone, I'm Navid Ali and welcome to SatLab Marine Division. It is a pleasure to be here introducing the SatLab Marine and Water product range. Over the past few years, we have seen many requests from marine and hydrographic sources, and we are aware of the great needs and potential in the marine sector for making our lives much safer and better. Like the UN Seafloor 2030 project, where they plan to map the global seafloor within 10 years. Our exploration of the water is surging, and in order to better serve our customers and clients, we are now offering our solution of marine and water resource to unlock subsea insight. I believe you will enjoy the presentation. Do feel free to contact us for your interest or any other questions. In today's session, we are going to introduce 5 kinds of products that are frequently used in shallow waters and offshore. Products like the ES224, a dual frequency echo sounder that can serve in many scenarios and applications, whilst the split design high precision GNSS heading receiver called NORD, which is best fit for the navigation and construction purposes in shallow and inland waters, also for nearshore and offshore. Hydroscan series sonar may be ideal for versatile applications by having clear and high resolution subsea images at all times. Also, river discharge measurements products such as Hydroflow is used for industries related to water resources by its stable and precise measure. Last but not least is the mobile bathymetry platform, the Hydroboat 990 USV. Beginners will find it easy to learn and operate without the safety concerns, whilst seniors will be satisfied by its operational efficiency, robust performance, and accountable bathymetry data. Let's start with our GNSS heading receiver, also known as the NORD. Position and heading information is an essential base of maritime activities. This information builds up the project's location and success of the facility's establishment in any purpose and scenario. However, offering precise and stable positioning and heading is not enough. What is a maritime heading receiver on demand? We interviewed many users to find out what they thought and what was most important to them. Let's see what we found out. Position, heading, performance, and stability in different scenarios are the basic requirements, but there are more behind these. Compatibility, consideration like new and old format support, multiple position framework, signal and ports support for 3D party maritime systems like multi-beam echo sounders. Users are also considering their data privacy and data security, and considering and wondering how to get their data back if they forget to or are unable to have the positioning augmentation services. For NORD, the heading GNSS receiver, named after the maritime god Norse mythology, is the product to answer all these questions, a maritime GNSS receiver on demand. Okay, let's talk about the features of the NORD one by one. Firstly, the features relating to the performance of position and heading. It has the latest GNSS engine with 1,408 channels with full constellation tracking with anti-jamming algorithm for data guaranteed and dual mode for data flexibility. The dynamic mode makes full use of the Kalman filter and epoch processing technology, making the tracking results stable in different scenarios and tough conditions. The static mode can offer precise positioning with the millimeter accuracy without sacrificing speed. NORD supports post-processing technology for normal practice like PPK function, but also PP and PPP users can recapture fixed solutions with 99.9% success rate globally if they forget or are unable to access any satellite-based PPP service during the work function, not wasting the voyage and saving the cost. Okay, operation compatibility. The most commonly asked question about compatibility during user daily operations are data format and frameworks. Now, we are proud to announce that NORD supports the latest and most precise frameworks. ITRF 2014, data output in the framework that can be in real time, and EGM 2008 is also programmed into the device, together helping users to check tide and height anomaly calculations. To name a few features, IP67 rated, safe if dropped at 1.2 meters, also known as a safe drop rating. It has been tested for salt spray for 96 hours, and it's very lightweight at only 1.25 kilograms, and many more. We have 2 antenna connections, which is one, the standard UHF. We have a 4G light antenna SMA port. We have RG 45 gigabit Ethernet port, and many others. To name a few scenarios where Nord can be applied: energy prospecting, wind and energy installation, laying cables, marine navigation, area measurement and dredging. Let's move on to the echo sounder. Actually, in the past, SatLab offered a portable and handy echo sounder, also known as the SLD 100, which was fit for mapping and surveys of lakes and rivers. But when it comes to hydrographic surveying for engineering purposes, we are yet to satisfy our users. So now we are happy to announce SatLab's first dual frequency single beam echo sounder, the ES224, for a better user experience for more challenging projects. ES224 consists of 3 main parts. The first one is the echo sounder box with a Windows-based operating system for operation and post-processing, a dual frequency transducer, and a user-friendly software called SL Hydro Sounder. Taking a closer look at the hardware of the echo sounder box first, we have the 17-inch screen, which is protected by a strong glass which can withstand the force of a punch or a collision. With shortcut buttons and Windows-based operating system, the ES224 can be easily operated by many users. Plus, all the buttons and ports are water splash proof, and the body is anti-corrosion, built for the harsh sea environment. Okay, as you can see, the depths in each screenshot are very different, becoming deeper and deeper. We tested the ES224 in deep ocean environments in order to make sure that it can satisfy our customers who are deep sea familiar. Close to us, one of the biggest applications for dual frequency echo sounder is to measure the sediment of the waterbed. As we all know, that lower frequency can penetrate deeper layers of the seabed. Depth result measured by low frequency and high frequency are different. So by calculating the difference of the results of low frequency and high frequencies, engineers can easily calculate and show the thickness of the sediment and help, which is in turn them better to organize and plan their projects prior to execution. This function can also help users to check the results of dredging, whether it is done and met as per the project's guidelines, or furthermore dredging work is required. The ES224 can adapt to many different transducers, so as long as the physical port is of the same type. If you would like to use your own, be our guest, and it is possible. You can get in touch with us, and we can further tailor the solution to meet your requirements. Our solutions work well with many third-party low-frequency transducers. Precision has always been one of the key factors of an echo sounder. To find out how well it performs, we had made a test with a well-known brand dual frequency unit. Firstly, let's take a look at the internally coincident precision. We had checked the result differences of the cross points of 2 lanes, as you can see in the slide. High frequency is more than 85% of the water depth difference at the intersection of 0 to 5 centimeters, and low frequency is more than 90% of the water depth difference at the intersection of 0 to 10 centimeters. That means the coincident precision is good. We now checked with the external coincident precision with a third-party echo sounder, and here is what we found. As you can see, 86.4% of the total high frequency are within 5 centimeter, and 83.8% are within 10 centimeters for low frequency. You be the judge. In the chart, when sampling, the dense red dots represent the dense echoes. Based on the echogram, the software calculates the digital water depth value that is easy to export, and the blue line covering the red dots is the digital water depth value. We can easily tell whether the digital water depth and the echogram have deviations, having the data processed much faster. The higher frequency signal at 200 kHz has a higher resolution, and the maximum depth measurement is no more than 300 meters. The lower frequency signal has a stronger penetration ability, which can detect deeper water bottom on one hand, and also discern whether there are sediments in the water or not on the other hand. Hydroscan. Side scan sonar, also referred to as side looking sonar or side imaging sonar, is a type of sonar system that is usually towed off a survey vehicle and emits sonar pulses to the seabed. Side-scan sonar is used to effectively create images of large areas under the water. Like all sonar equipment, the frequency with which the side-scan is equipped is key to its performance. Hydroscan is equipped with dual frequencies ranging at 100 to 400 kHz and 400 to 900. Or you can choose the more portable 900 kHz single frequency side-scan sonar. Smaller beam angles result in clear images of the seafloor. An abundance of built-in sensors can correct the attitude of the side-scan sonar, providing more reliable data. The 1400 and the 4900 have smaller beam angles with good accuracy. It's sturdy and it's large in size with approximately weight of 30 kilograms. The larger volume makes the 1400 also more capable in sounding depths with 100 kilohertz range, reaching in depths of 450 meters. High frequencies such as 900 kilohertz, the deepest depth measurement is 75 meters. The 1400 and the 4900 also have more inbuilt sensors. 400 and 900p are the more portable. Hydroscan 900p is only 1.5 kilos in weight, which is more suitable to be used and mounted on USVs, and the maximum depth measurement is about 75 meters, suitable for inland lakes and rivers. Say for example, in the picture you can see we installed the S900p from the moon pole in the middle of the boat. The interpretation of the side-scan images is also an important task. The 100 kilohertz image data is less dense than the 400 kilohertz image. However, the 400 kilohertz has a higher resolution, so we can see in more detail on the 400 kilohertz image. Hydroflow. Acoustic Doppler devices use sound waves and the Doppler effect to measure the velocity fluctuations underwater. In the past, water flow can be measured in many different ways, such as rotating element current meter, float run method, slope area method, and now we use acoustic Doppler devices to quickly and accurately measure water flow. What we have done is we have launched two different frequencies on ADCPs for you to choose from. The Hydroflow 600 and 1200 both have gyro, temperature, pressure and tilting sensors built in to correct for attitude errors during measurement. Long profiling range multiple cells satisfy your most inland river needs. We had tested our device in a test environment and compared it with our partner's device. The accuracy of 0.25% plus or minus with 0.25 centimeters per second. Multiple installation options and professional software for outputting water volume reports, which means you can get the water flow data at your fingertips. 600 and 1200 kilohertz parameters seem to be the same. Different frequencies allow them to have different bathymetric capabilities, one for 75 and one for 35 meter depth. Of course, in addition to bathymetric capabilities, they have a big difference, which is the cell depth. 1200 kilohertz can identify up to 0.06 meter cells, measuring water flow more accurately. This is our flow measurement software. In the middle displayed is the data of a river cross-section. The data appears to be green, indicating that the river flow rate is around 1 meter per second. On the left-hand side of the cross-section, we can see that the depth of the river is about 12 meters. The ADCP is usually fixed underwater or mounted on a survey vehicle or USV. There are also several different scenarios where it can be installed on a survey vessel. In the last images, the ADCPs that are bottom mounted need an anchor to keep them on the bottom, batteries and an internal data logger. Vessel mounted instruments require power, a shipboard computer to receive the data, and a GNSS navigation system, so the ship's movement can be subtracted from the data collected. The ADCPs have no external readout, so the data must be stored and manipulated on a computer. If used on a USV, the ADCP data will be sent back to shoreside current measurement software through communication systems. Lastly, Unmanned Surface Vehicle or USV. We call it the Hydrobot 990. We plan to release more products in the future, including USV and MBES, which is multi-beam echo sounders. Stay tuned for our product release updates towards the end of October 2022, where we will release a very popular and smart operating system, the first USV of the Hydroboat series. A safe, reliable, easy to operate, easy to carry SBES USV. Just to let you in on a secret and to inform you in advance, it uses an Android-based software for its measurements. On behalf of SatLab, thank you for attending the launch of our new marine range. My name is Navid Ali, and I look forward to seeing you at Intergeo 2022. Please do drop by and say hello. Thank you and goodbye.